Good afternoon, ladies and gentlemen, and welcome to Algebra 2 Honors, and again to room 15, where it never ends, but it did end for a while, or was delayed, or so postponed for a while, over a long weekend. Hope you had a good weekend. What I want to do right at the beginning of class, before we resume on where we left off last Thursday, is to look at our learning pyramid. I think I talked about this earlier in the year. I think it bears reminding.
I don't think so.
Of why.
I've never seen it.
You've never seen it?
No.
You don't remember it? What this is, it kind of explains why we do things like we do in this classroom. And it has to do with you have better learning retention as you go lower in the pyramid. So basically, if, according to this pyramid, if I talk to you just during class, whole class period, with very little break, there's going to be very little retention because there's not much interaction. And another thing is that as human beings, we tune out things that we already think we know what are going on, right? Like during the announcements, do most people know what the announcements are going to be pretty much?
Yeah.
Yeah, pretty much you do, but when you hear something, you can just tune it out. Oh, I already heard it, right? And this is not because you have bad behavior or anything like that. That's natural. If I go into hear a lecture, it'd be the same thing for me, right? And so what we try to do is we try to do less of these types of activities and more of these types of activities. So in this classroom, how do we do more of these kinds of activities on the bottom as opposed to the ones more on top? How do we do that in this classroom? Okay, first of all, you have time to discuss with each other, right? And then practice doing problems. And then you're going to, in discussing, what are you going to do to others? You're going to teach others, I hope. Anyway, that's the plan and that's the hope. But what's the downside? What's the price we pay for doing things this way?
We go slower.
Yeah, we're gonna go slower. We're gonna go more slowly through the material. So we're gonna have more time to work on. So that's kind of. Or you haven't seen this before, Madeline? You haven't seen?
The learning pyramid?
You haven't seen it before?
Not in your class at least. I mean, I've seen some kind of pyramid.
I've
Okay.
never seen that before.
You never have. Okay.
I've seen a pyramid in biology before.
Okay. Well, this is just an explanation for like why are we doing things like we do in this classroom. There's really a reason for it. So that's the reason for it. But in order to make this a good reason, you have to you're given more independent time, aren't you, to work on this. So I want you to just consider this as we go forward today and other days. And so we go back over here to, I think we left off after problem 3 yesterday, or Thursday, didn't we? Finished problem 3.
I have no idea.
I think we just did problems 2 and 3 on Thursday, didn't we?
I think.
Yeah. And so you should have problems 1, 2, and 3 done if you're caught up in the class. Is that right?
Right.
Is that what you have, Jaylee? Okay. So, anyway, what we're going to have is, just as a reminder, just the vertex form, except it's not strictly vertex form, because it's not a vertex. We have a times quantity x minus h cubed plus k. All right? And so it's a matter of what do these different things do? Well, the a does what? The a it'll do what?
It distributes.
Transform.
Yeah, actually, you know something, Madeline? Now, if you had x minus h to the first power, you could distribute. What we're doing is we're leaving it in this form, so we're not going to distribute that a. We're going to leave it right there. What we're going to do is a controls, and Jaylee has told me this before, controls the what?
The width.
Width and narrowness. And if negative, what happens? If negative, what does A do?
It widens it.
reflects about the x-axis. Okay? And what is the role of the h here? Anybody remember what that is?
H subtracts.
What this does, this translates horizontally. And it's the same thing for absolute value functions and for quadratic functions, which we've already done. And what does this k do?
Adds.
Translates vertically. So these are the types of transformations we're going to be performing on these ones up through, I think, number 10 or number 8. Yeah, we're going to do those through number 9, okay?
Doing all the way through number 9 today?
We should be, yeah. Should be going through number
Yeah,
9
that's
and number 10, 11. That'll be fun. So what I'm going to do is I'm going to call on people, and you can just check with your calculator. You should probably already know a lot of these things, but I'm going to call on people to help out with this, okay? And help each other. I'm going to call on somebody in a minute.
When's our next test?
It'll be after chapter 6. It'll be a little bit because we got to really get through chapter 6.
Our next test is after chapter 6.
And this is section 6.1, so we're kind of beginning the section. So we're not going to have a separate test on section 5. 5 was systems of equations and systems of inequalities.
I really thought you were just yeah, I don't know how to.
Okay, for this one here, for number 4, we have Brian. So basically what these problems start out with, they start out with the same thing that 2 and 3 start out with, which is g of x is f of x. And remember, it's f of x is equal to x cubed. So g of x is f of x what? How do we get from f of x to g of x? What do we do?
That's the g of x. I don't know. See, we got subtract 2, divide 2.
I don't see a subtraction or a division
Well, I see
symbol
a
here.
plus, so I see like plus 2.
So what does it do? What is happening here? Well, how do we get from here to here? What kind of graphical transformation did we make? So here, let me just show you.
Okay.
So here we have this. Here we have this one here. Who doesn't have it?
Wasn't here Thursday.
Okay. So, what we are taking this one right here, that's f of x equals x cubed. We are taking it and we are doing what with it?
Going opposite direction.
We're taking it and we're going like this.
Yeah, correct. So we're going
So what thing are we doing here?
Going up.
Going up,
And how do you say that?
where,
What's the word for that?
what letter does it start with? I know it.
How about T?
Oh, we're transforming?
Translate.
Translating?
So translated, where, and how much? Translated which direction?
Right, oh, up and to the right.
Up,
No,
no, up.
Up, how many units? 2
So
units.
that would be 2 digits.
Okay, is that all there is to this one?
No.
Yes.
Yes, it is.
Oh, we use,
Okay, so that's all there is to it. Now, on number 5, what you have is, I'm going to rewrite this. When you take 3 cubed, what's 3 going to be? What's 3 cubed going to be? Yeah, somebody said it here, Jaylee, or somebody said 27. Was it you, Jaylee? 27x cubed, that's what you're going to have. So I want you to do that one. I'm going to call on somebody in 2 minutes.
Look, Jackson.
I did this time, I remember.
I see it.
So thank you for reminding me again, that was helpful.
You're welcome. I thought you were. Actually, it was my birthday.
I was just thinking of that last night when I was doing these gradings.
After the honor service week. And have it one. This one's in.
Well, I hope everybody had a good break.
What size in kids? That is small.
Yeah, I'm gonna call somebody here in half a minute. So 27x cubed, right? What is happening here?
I can get one back, Mr. G.
I'm gonna still hand them out. I still have more to hand
Oh,
out.
okay.
Yeah, so don't, I appreciate you saying that. Okay, we have for number 5, we have Charlie. So what role is our 27 doing to this guy here?
I got 2 stars on that one.
Yay. Thank you, Mr. Beach.
One thing we do quick. Is that Thompson? The calculator? Do you use a separate calculator? And see what the difference between them. Why do you feel like you want to I don't either. He said,
No, he's
Okay, Charlie, what'd you got? What'd you get?
The gym is gonna be outside of that.
Off the street.
So what'd you get? So we'll start out, f of x, or g of x is f of x. What is happening here? Remember, f of x is x cubed. How do we get from x cubed to 27x cubed? What kind of graphical transformation happens? What is that 27 doing to that x cubed here?
What is what, X cubed?
What is that 27 doing to that x cubed?
Oh, I don't know.
You don't know.
I need a calculator for that.
You don't know what that 27 is doing to that x cubed. Who knows
No.
what? Who
I
knows
thought you
what?
said what is 27x cubed?
What is the 27 doing to that x cubed?
Making it. I'm stretching it.
It is what? What'd you say?
Stretching it.
Stretching it which way?
Vertically.
So vertically,
Vertically
Stretch.
stretched by 27.
yeah. So vertically stretched by. Stretched by a factor of 27. Now, this is one thing that I say that I don't hear other teachers insist as much upon, like to say factor. Why do I insist that saying factor is a good thing?
Because it's a math word.
It's a math word, and it's a math word that means,
A value.
what does a factor do?
Multiplies.
It multiplies, okay?
G, where did you get 27?
Okay, I got a good question. Charlie asked, where did 27 come from?
I figured, can I answer?
Yeah, go ahead, Ashton, answer that. That's a good question.
Okay, yeah, sort of like just confused zero, but then I figured it out. So notice how this 3 is on the outside. Usually you're thinking right now it's 3x squared, but it's not. It's distributive property. So basically instead of it leaving it as is, you put that 3 on both of these numbers, and then 3 to the power of 3 makes 27.
Good job, thank you. That was a good question, Charlie. Thank you for your question. That's a good question. Yeah, it's simplified. Okay? Questions on that? Are we good on that? Any questions on that? We're all good on that? Okay, good. Okay. Let's go on to number 6. Okay, again, we have another type of transformation going on here. So what is going on with this? And again, it's similar to what we've done for absolute value functions and for quadratic functions. So this translation business should be nothing new to us. Now, it's probably been a while because we didn't do these translations since last semester, did we? So that could be a little bit of time. Yeah, it's going to say g of x is f of x blank. And we have Ashton. So what do we get for this one, Ashton?
been long on the break. I think he's tired today.
Yeah.
Yeah, everyone has bad days.
It's okay, in fact.
Yeah, but it's okay.
You get your Chromebook?
No, they're gonna send it to technology.
Oh, okay. So are we translating up one unit here? Is that what we're doing?
I said to
I
the
think
left.
I thought it was to the
I
left.
said translate to the left. Up.
That's because you're thinking in parentheses, but the reason these parentheses are here is because of this. And we just established in the last problem, these parentheses will go away once this is distributed properly. Right?
Yeah, well, the thing about it is, let me see.
Like conference, I still put 1 unit to the left.
Yeah, we're translating one unit to the left. Let me see if I can show. Look here.
Oh, I looked at this problem.
So you're correcting it? Yeah, so right here, yeah. Yeah, left by 1 unit. So yeah, right here. Okay. Yeah, so it's a matter, this is going to be x minus -1, right? With the x minus h. All right, thank you for that. Good work. And I want to thank Ashton. I want to thank, who is it that found Ashton's mistake?
Carly.
Carly, you found it first? All right, did you? That was really good. Good work. Appreciate that. Thank you, Ashton. Okay, ready to go on number 7? Okay. All right, number 7, we have number 7, we have Chelsea, who's been away for a little bit.
You haven't been here though.
Yeah, she hasn't been here, but Chelsea, think about it. We did the same thing with
I had to come back and get this.
We did the same thing with absolute value functions and quadratic functions. So you can work this.
Mr. G, she has the videos.
Okay, I'll say what I get. It's the second time I responded to it, just for you this time, okay? So you're going to say it again. We did the very same thing when we did absolute value functions and quadratic functions. So the principle's the same. So, yeah, she hasn't been here for a while, but the principle of what this thing does is the same we've been doing since first semester, right? And she looks like she's doing something with the calculator. And if she has questions with that, who can she talk to about this?
You.
Brian, that's what he's doing.
Brian,
Ashton.
Chelsea, Bryce. Charlie, Carly,
Ken,
Ashton,
Well,
Kimberly,
she can't talk to me.
Maddie,
You never said Madeline.
Madeline,
Emily, all the way on the other end.
yeah, Jamie,
Jenny,
brother,
is that one too?
Ronald Work, Michelle, Nolan,
No?
right?
Savannah,
Savannah, yeah,
Lily,
everybody here. Lily?
Pete, guys.
So what is that 1/4 doing to that x cubed? As a reference, you can look at problem number 5, right? Let me look back to number 5, make sure I'm saying the truth here.
Or 3.
Or 3, well, 3 is a different, in a couple ways, thing. Well, I see what you're saying.
Yeah.
Well, I'd look at 5 here. So what is, so g of x is what? G of x is f of x. What is, and remember it's f of x equals x cubed. So g of x is f of x.
I think I got it yesterday.
Okay, go ahead.
I think it horizontally stretched by 1/4.
Horizontally stretched by 1/3.
1/4.
1/4. Well, it's, you know something, but I want to talk about in terms of verticality though. So horizontally stretched, so we'll say vertically compressed, which is similar to horizontally stretched.
So it's going in?
Yeah, I'm going to draw what that is pretty soon.
So it's vertically compressed?
By a what? By a factor of
1/4.
1/4. Now, in the way the textbook has this thing, they have this thing, if you look at, I don't have the, they also have it, you can write these like f of x equals a, and then you have 1 over b, then you have x minus h cubed plus k. And in this version here, the b will have to do with horizontal compression or stretching. But this a out here, you're going to define that as a vertical. That's the way the textbook defines it. And even if it's like this out here inside the parentheses, I like to bring it out like we did in problem 5 to make it a determination of vertical stretch or compression. Okay? Questions on that? Okay, what does that look like? Basically, it looks like this. It looks like you have this function here of x cubed, and you vertically compress it, and it'll look like this. It'll flatten out some, right? So that flattening is a vertical compression. And did Chelsea, did you graph those in your calculator? Take a look at it. It looks like that, right? Vertically compresses. Okay, good, thank you.
Yes.
Oh, we have someone with the hiccups.
It's not me this time.
It's not Haley this time. So go ahead and do number 8. I'll call on somebody to do number 8 here in a minute.
You're doing with a capital H.
Okay, for this one we have Nolan. What is that minus 3 doing to everything inside this, in this function here? What is this minus 3 doing to everything in this function here?
Making it go down,
How do you know it's going down?
because it's negative.
Yeah, because it's subtracting everything, right?
Right.
So we go like this, x, f of x, and then we put right next to it g of x. So we got x, -2, we get -8, -1, -1, 0, 0, 1, 1, 2, 8. And so g of x is going to do what? If we subtract 3 from each of these, what do we have? What does -8 become if we subtract 3?
Negative 11.
-11,
Negative 4.
-4,
Negative 3.
-3,
Negative 2.
-2,
5.
5. So what is f of x, g of x is f of x what? I'm still trying to get Nolan involved here. G of x is x of x what? Okay, we have a few things here, right? We have translated horizontally, translated vertically, reflect about the x-axis, vertically stretched, vertically compressed. Which one is this going to do?
You're gonna vertically compress this.
Vertically compressed,
Translate down 3.
vertically compressed is this one here.
Yeah, so I was gonna translate down 3.
This is f of x translated
Yes.
which way?
Down 3 units.
Down 3 units. Right? Okay, is that very hard? That shouldn't be, right? Should be easy. Okay, this number 9, we have this one here. I'm going to go ahead and take the cube of this here. Negative 2/3 cubed is going to be -8 27ths x cubed. Okay, what's happening here with number 9? Call I only have a couple people left here. Okay, this one here we have Savannah. what Savannah is going on here, number 9. I don't know how well that's adjusted. We will see.
Good enough.
Good enough, she says. Yeah, it is pretty good. Okay, thank you. Does that sound right?
Oh, hang on.
Yes.
Here you go. Yeah, there you go.
Oh, okay, I see what you're doing.
Yeah, no, I did it on mine, I just couldn't do mine.
Oh, okay.
Yeah,
Okay.
thanks.
Yeah, the thing about it is, the only thing I would like to say here, I'll just make a minor correction because this is largely correct. The only thing I would say is I'd say vertically compressed by factor of, what I would do is I'd make this by factor of vertically compressed by factor of 8/27ths and then reflect about the x-axis, okay? Everybody good on this one?
No.
No? You're not good on this one? Are you gonna be good on this one?
Yes.
Should we go?
About 2 seconds.
Okay,
No, Mr. G, don't go yet.
You said probably June to 9.
what might, I wanna look at
You
10
have
though.
low movement.
That's fine. There's time.
Factor of
Okay. Number 10, we have this right here. We're gonna transform this one. Yeah, we'll finish this one tomorrow. But what's 1/3 cubed?
1.
No? 1/3 cubed is what?
3. 1/9.
No,
1/27.
1/27.
Yeah, I got it right.
So x cubed is what this is gonna be. So we're gonna go ahead and transform this tomorrow. And it shouldn't be bad. We'll leave it there.
Huh?